Well, now that we have some conceptual understanding of relative minimums and maximums, where they occur at critical numbers, we actually want to begin using algebra to find the critical numbers in functions. And this is a step on our way towards using calculus then to find where minimums and maximums occur. So what we want to do here is to find critical numbers of any function, of these functions that are listed. And I'm going to do the odd ones. Hopefully I'll finish them all on this one video here. So I'm briefly going to write down what it is that we do to find the critical numbers of a function. And the first thing we do is find a derivative. Second, we set the derivative equal to 0. Third, we solve for x. And lastly, we want to see if there are any x values for which the derivative does not exist. So this is our basic strategy, and let's see if we can find for 11 through 13. So for number 11, we start with f of x is x cubed minus 3x squared. Find the derivative. That would be 3x squared minus 6x. That's pretty easy. We set it equal to 0. And how are we going to solve that? Here it's just a matter of factoring. We'll factor out a 3x, leaving an x minus 2 is equal to 0. Therefore, x equals 0 or x equals 2, and those are the two critical numbers. Polynomials are easier to work with. Some of the other functions will be a little bit more difficult. All right, next, let's look at number 13 then. 13, we start with g of t is equal to t, and I'm going to rewrite 4 minus t to the 1/2 power. And we're told that t has to be less than 3. So, finding the derivative, g prime of t, notice we have a product as our basic structure, so we're going to have to use the product rule, and then we have a function composition in one of the factors, so we'll need to use a chain rule inside the product rule, which makes it a little more complicated. So we have 1 d2, and so I'll put that in parentheses. How do we find the derivative of 4 minus t to the 1/2? Well, we bring down the 1/2, leave the inside alone, reduce the 1/2 by 1, giving us negative 1/2, and then take the derivative with respect to t, 4 minus t, and that's just negative 1. So that's the first part. So it's 1 d2 plus 2, which is 4 minus t to the 1/2 times the derivative of t, which is 1. Alright, so we'll clean this up just a little bit, and we're going to get negative t over 2 times 4 minus t to the negative 1/2 plus 4 minus t to the positive 1/2. Now the only way we're going to be able to solve this for 0 is by factoring out the least common multiple. And that is going to be 4 minus t to the negative 1/2. We always take out the smaller of those. Negative t over 2 plus, now we have 4 minus t. The question is, what does the exponent need to be there? Well, when we multiply two numbers with the same base, we add our exponents. So what do we need to add to negative 1/2 to get positive 1/2? We're just going to add 1. And so that makes that a lot simpler to work with. 4 minus t to the negative 1/2 now times negative t over 2 plus 4 minus t. And we'll simplify that a little more. Negative t over 2 minus t, that's a negative half of a t minus a whole of a t, so that's going to be negative 3/2, is 4 minus t to the negative 1/2 times negative 3/2 t plus 4. A lot of algebra involved there. So we factored it. Now we can set that equal to 0. And the function on the left is negative, has an exponent of negative 1/2. And so that will cause the derivative to not exist when t is equal to 4, but we're told at the beginning that t should be less than 3, so we're not even going to worry about the 4 minus t to the negative 1/2 in this case. So all we need to do is negative 3 over 2t plus 4 equals 0. We get negative 3 over 2 t is equal to negative 4. If I were to multiply both sides by negative 2/3, I get t is equal to 8/3. And that would be my only critical value for number 13. Now, as I said, there is a place where the derivative doesn't exist at t equals 4, but that's a separate issue there. Next, number 15, trigonometric function. Number 15, we have h of t is equal to sine square of h of x, sorry. And h of x is sine square of x plus cosine of x. We need to find the derivative, h prime of x. And here we have, firstly, a chain rule. We have the inside function sine, the outside function something squared. So we're going to deal with the outside function first by bringing down the 2. Leave the inside alone, reduce the exponent to 1. Then we're going to multiply that by the derivative of sine, which is cosine of x, and then plus the derivative of cosine, which is negative sine of x. All right, so at this point we set that equal to 0. We want to factor a sine of x out. We get 2 cosine of x minus 1 is equal to 0. So we have two expressions here. We have sine of x is equal to 0, and we have 2 cosine of x minus 1 is equal to 0, or 2 cosine of x equals 1, or cosine of x is 1/2. And we can only use values from 0 to 2 pi non-inclusive, and so therefore sine is only 0 when x is pi, and cosine is 1/2 when x is pi over 3, or x is 5 pi over 3. Right? And that does it for these 3 examples here. Now, I do want to show you how to use your graphing calculator very briefly. I'll only do the first one, but you can do the others after that. So we'll go ahead and put in the function x to the third minus 3x to the second, and I'll always zoom standard, and we get our function there, and we can see that indeed it appears that we have a horizontal tangent when x is 0 and one when x is equal to 2. Right? So just in case you want to do this, you go to second calc, you have a maximum, number 4, and what you have to do is you have to go a little bit to the left, then go a little bit to the right, and then hit enter for guess, and it gives you this value, which is essentially 0. You have 1.15 to the negative e to the negative 6, which means you move the decimal place 6 places to the left, which is essentially 0. So we check that out, and then we'll do something similar for the one on the right. That's a minimum, so we move our cursor just to the left, then just to the right, hit enter for guess, and we get at x equals 2 we have the minimum y equals -4, and so that one checks out as well. Now you can do this yourself for the remaining ones, and I really encourage you to do that. You can see how the calculator could do all of the work for us. We could find all of these answers just using the calculator functions. Unfortunately, we can only use it to check our work in this case. Alright, I'm going to stop this video here and go on to the next set of exercises.